Hi everyone. So today is another episode of the 8th class. And today our topic is going to be what? Building and logic gates. And what do you mean by logic gates? Logic gates actually refers to the building blocks in electrical circuits and electronics. Because the CPU in your laptop, the CPU in your phone consists of logic gates. And one of the logic gates is the what? And logic gates. So today we're going to be building an AND logic gate with transistors. So now what is an AND logic gate? This is the truth table of an AND logic gate. Logic gate. So the truth table is input 1, input B, and output. Input A is 0 and input B is 0. Our total output will be what? 0. When input A is 1, input B is 0, our total output will be what? 0. When input A is 0, input B is 1, our total output will be what? 0. And when input A is 1 and input B is 1 also, our total output is going to give us 1. So it means that in an AND logic gate, for you to have an output of 1, your two inputs must be 1. But in electronics, 0 means off, while 1 means on. So it means that if you want to get an output of 1, that means if you want to allow your output to be 1, it means that you must turn on input A and turn on what? Input B before you can have an output of 1. And this is the circuit diagram when using a transistor to create a logic gate. This is the first transistor and this is the second transistor. This is where the output is going to be. Output. And this is the input. So this is transistor A, this is transistor B. Now what is going to happen? If we do the first one, if transistor A is off, nothing can flow through from here to this place. If transistor B is off, nothing can flow through from here to this place. Now let's imagine transistor A is turned on. That means our input is going to be able to flow from here to here. That's because of what? Transistor A was turned on. So our input was able to what? Flow from this point to this point. Then it will continue and move here to stop to this place. But we want our output to get out from this place. Whereas the only way it can get out is if this other transistor was what? Turned on. But since when transistor A was turned on, but transistor B was turned off, we can't get our what? Output. So I'm going to have what? 0. Now let's assume this transistor A was at 0. That means it was what? Turned off. But transistor B was turned on. That means we can have these two guys connected together. Yes, this whole place is connected to the output, but the main input, the main signal we want can't pass through because of what? Because of transistor A hasn't been turned on yet. That means that if transistor A is at 0 and transistor B is at 1, the output is going to be what? 0. But now let's assume transistor A was turned on. Then the input source can flow from here to here. Then continue, since the two guys are electrically connected. Then continue and reach here. And what? Transistor B was also turned on. If transistor B was turned on, it means that what? it also gets connected to this place and do what? Turn on our output. That to tell you that for an AND logic gate, the only way you can get an output of 1 is if the two inputs are what? 1. Input A is 1, input B is also what? 1. With that, we can get our output of 1. So let's build it together with our transistor. So this is our circuit diagram. As we all know, you must put a resistor at the base of your transistor to prevent it from cooking. That to prevent it from taking in much current. So you build this. I'm going to explain the circuit diagram. Now this is the circuit diagram. We're using two NPN transistor. So what we're going to do is the first transistor A and transistor B. You connect the emitter. If you have watched my previous transistor video, I explained that the pin having this diode diagram is the emitter, while the place taking in the resistor is the base. So connect your emitter to the negative of your power supply. And as I said earlier, if you are looking at the diagram of the cell, the one with this shorter leg is the negative, is the symbol of the negative, while with the one with this longer leg is the symbol of the positive. So now connect your meter to the negative of your battery and connect the positive to a resistor, then to your light, and the negative of your light you connect it to where? To the collector of transistor B. And now for these two guys, you might not need, this is just a symbol of a switch. You might not need a switch. What actually did was that the input for transistor A and the input of transistor B is coming from the positive power supply. So it means that in the video I'm going to manually touch it with my hand. I don't need to add a switch. So it means that if I connect this guy to the positive, it has turned on. This guy also to the positive, it has turned on. So that is the meaning. As I said earlier, once this guy turns on, this negative is going to flow from here to here and flow from here to here if this guy also turns on. And this is the truth table. A, B, output. 0, 0, 1, 1, 0, 0, 0, 1, 0, 1, 1, 1. So let's build it on our breadboard. So let's build it. Here I have my transistors, my breadboard, my lights, my LED, and my jumper wires. So you need two NPN transistors. You need one LED as your output. You need two 4.7 kilo ohms, or you can use 1 kilo ohms, but in my video I'm using 4.7 kilo ohms. You need one 330 ohms resistor, your breadboard, your power supply, and your jumper wires for your input. Now let's build it from scratch. So this is my black wire and I'm connecting it to GND. So now you can see. So the next thing for you to do is pick transistor 2, connect it to any place you want. So now after doing that, pick your jumper wires because you'll be needing it to connect the collector of transistor A. Connect the collector of transistor A to the emitter of transistor B. So after doing that, the collector of transistor B, connect it to the negative of your light, which is the shorter pin. You can widen the leg so you cover to any spot. And don't forget to add your resistor so that it won't allow your LED to get burnt. Connect it to the positive power supply, then to the positive of your LED. So after doing that, pick up your two 4.7 kilo ohms resistor. This is to protect our base, so connect it to the base of your transistor. That is where your two inputs are going to be. So you can see. So after doing that, we're going to connect our two wires to act like our input. So we're going to connect them to the base of each transistor respectively. So can you see? And connect the second one also. And we're done already. Now let's see what's going to happen. Because in our truth table, we said that if the two inputs are 0, our output is going to be what? 0. So now let me connect my power supply. This is negative of my power supply. The positive of my power supply. Now can you see my power supply is turned on already? My power supply is turned on already, but the light didn't turn on. Now that's what's going to happen. Our truth table said that if the two inputs are 0, our output is going to be 0. So let's see what's going to happen if we make input A 1 and input B to be 0. So let's see what's going to happen. We're making input A what? 1. So now can you see? Our power mark is still turned on. So now can you see? Input A is what? 1. While input B is what? 0. That means it's not connected to our power supply. And with that, our output is what? 0. So now let's do the next one. And what is the next one? The next one is when input A is 0 and input B is 1. So let's disconnect input A and make input B 1. So output is what? 0. Because of what? Input A is at 0 and input B is at what? 1. So now let's make the two inputs 1 and 1. So input A, let's make it 1. And input B, let's make it 1 also. So can you see that for an AND gate, until the two inputs are 1, before our output can be 0. If our input A was 1 and output B was 0, that's what's going to happen. The output is going to be 0. And if our input A was 0 and output B was 1, that's what's going to happen. Can you see? So it means that for you to have an output of 1 in your AND gate, your two inputs must be what? 1. So that is that about the AND gate. So it means that for you to have an output of 1 in your AND gate, your two inputs must be what? 1. So that's going to be all for today's class. Thank you.